Hey guys, I am super sad to be missing time with you, but I have sick kiddo, so we are home for a while. So isn't technology fantastic that we can still have class and Miss Shepherd just has to push play? Isn't that fantastic? So I miss you guys. Hope everyone had a wonderful week. I wanted to hear all about the basketball games and everything that was going on, but what I'm going to do is we're going to work through our different lessons. I'm going to break it up into small little sections. We're going to cover one little concept at a time, and then I'm going to give you some practice problems to work on the board. So we'll pause the video or end the video at that point so you guys can work the problems out on the board, and then we will move on to the next section. Okay? And if my internet wasn't so bad, we would try to do a live stream, but I will still be available if you guys need me. Alrighty, so last week we started talking about quadratics. And so the thing that's different about quadratics compared to what we've been doing is that quadratics have an x squared term. So automatically, if it has an x squared term, it is called a quadratic, okay? Now, the thing about quadratics is that they can be solved about 5 different ways, depending upon what all is in it. So ultimately, our goal is to get an answer for x, correct? But to do that, we might have to work through a couple of different ways of solving it. There are some that are easier than others. There's a formula that's a shortcut, but we're gonna walk through each of the types of solving for x, because remember, all we're doing is getting an answer for x. So that is what we are trying to do. That's the question that we are trying to answer. We're going to use all of the tips and tricks that we learned from roots, the tricks that we learned from exponents, our factoring, our greatest common factors. We're going to use all of our basic math skills, and we're going to apply it to find an answer for x. And yes, there are real life solutions and real life problems for this. Okay. So first, when we talk about a quadratic, often it just has an x squared term. So if I have x squared equals 25, this is a quadratic equation, okay? It has an equal sign, it has an x squared. It doesn't really matter that it doesn't have anything else in it. There's no other constants, there's no other variables in it. This is still a quadratic equation, okay? So in this one, as we've been learning, when we have our PEMDAS, right, we want to always get our x all by itself on one side. And then we're going to use our undoing. Well, because we have an exponent, we undo it with a radical, remember? So the opposite of squared is to take the square root. So when we take the square root of x squared, we also have to take the square root of the other side. Math rule, where what you do to one side, you do the other side. Well, we learned that when what we need is 2 and what we have is 2, they cancel out, and all we have is what's underneath. So we have x, and the square root of 25, we could rewrite that as 5 squared, correct? So I need 2 values that are the same. I have 2 values that are the same. My answer is simply 5. Now our catch was, we went over this briefly last week, that when we are dealing with a square root, our answer is not just 5. Because when we have math problems, remember, a positive times a positive is a positive number. But also a negative times a negative is also a positive number. So when we solve with a square root, we're going to say plus or minus. Because the answer could be 5. I could go back in here and say 5 squared is 25. That checks out. I could also go back in and say negative 5 squared is 25. That also checks out. Now the thing is, sometimes those answers just don't make sense. So we're going to work through a problem where it often just wouldn't make sense. And I don't have a eraser. It's somewhere around here. Okay. So, around here we have a whole lot of buildings going up, a whole lot of neighborhoods going up. Okay. So, if there is a builder who has 23 acres of land, so we know that his total acreage of land is 23 acres, okay? He wants to put different size lots on there. It tells us that he's got 3 1-acre lots. Now, they're all square, and when they're 1 acre, that means we've got 1 on each side, correct? So we've made it here. So I have 3 1-acre lots. So I'd write that down as my information. 3 1-acre lots. Now it says he wants to divide up the rest of his land into 5 equal square lots. So he's got to get 5 lots here that are square. So when something is square, we know that both sides are the same. If we are finding the area is now x squared. Okay, so he has 5 of these bigger lots. We don't know what size they are, but we know that they're square, and we know that they're all going to be the exact same size. Okay. We also know that the ones that they told us were 1 acre and the 5 extra ones will all add up to 23 acres. Okay, so at this point, we look at it and we say, I want an answer for x. I need to solve for x. Now, we can still use the same rule as we talked about with going into the movies. We want to get x all by himself. Who do we get rid of first? So our goal is to get x all by himself, and then we will deal with him. Okay, so we know that 3 times 1 is 3, plus 5x squared equals 23. Now, the easiest one to get rid of is 3. X wants to go to the movies by himself. We're going to get rid of 3 by subtracting 3 on both sides. I now have 5x squared is equal to 20. Now, X still wants to go to the movies by himself. He's got a 5 on his back. We're going to divide that 5 off. And what we are left with is x squared is equal to 4. Okay. So now that we have our x squared value all by itself, we go back, say, how do I undo an exponent? I need to have a radical. So I'm going to take the square root of both sides. And we have the answer that x is equal to plus or minus 2, right? It could be positive 2 squared. It could be negative 2 squared. So then we have to look at the problem that they've given us. They are saying these are acre lots. You're going to put a house on it. Are you going to have a negative length of land? Are you going to put your house in a black hole? I don't think so. So the negative answer does not make sense for this problem. So we would just say that x is equal to 2 on that one. Okay. So as we work through these and we look at x squared without anything else attached to it, I'm going to go through a couple of examples, and then we are going to put some problems on the board for you guys to work. Okay? So I have, oops, sorry guys. All right, so we have x minus 6 squared plus 1 equals 14. Okay, so in this one, we still have an x squared value. At this point, it doesn't do me any good to multiply this out because my goal is I want to get x all by itself. I want it in the smallest form. So if I multiply it out, I've caused myself a whole lot more problems. Okay, so we are gonna view this as just one whole little section, right? X squared plus 1 equals 14. So what do? We get rid of the 1 first. So I now have this huge set over here. X minus 6 squared is equal to 13. Okay. Because my square is outside, this is my whole base, right? The x minus 6. Same thing. All I need is a square root of a square. So I'm going to take the square root of the left side, take the square root of the right side. My squared, I need to, I have to, they cancel out. Now my entire thing that's underneath gets left. X minus 6, because that was my base that was squared, is now equal to plus or minus square root of 13. So we want to solve x. It has a 6, so we're going to add our 6 on both sides. Our answer is x is equal to 6 plus or minus square root of 13. Now, when you write your answers, always move the constant to the front. We wouldn't want to write plus or minus the square root of 13 plus 6. Sometimes you will see it like that, but more often than not, we're going to move it to the front. That way, you don't lose that plus or minus. It's just an easier way to not lose it. Okay, so in that one, we had a base that was made up of both a variable and a constant, and we solved for that one. So let's look at another one. Let's look at one that has similar terms. Right? So we're going to think about this. The first thing that we do is, what do they want us to do? They want us to solve for x. Now, I want to simplify my problem before I can solve for x. I know that I have an x squared and an x squared. Remember, these are similar families, so all we have to do is combine the coefficients. 5 minus 3 is 2. So now I have 2x squared minus 4 equals 60. Who do we get rid of first? The 4. What you do to one side, you do to the other. So now we have 2x squared is equal to 64. I still want to get x all by itself, so I've got to get rid of the 2. So we divide both sides by 2, and x squared is equal to 32. I want x, not x squared, so we take the square root. I have to, I need to, take the square root. X is equal to plus or minus the square root of 32. Now, what we want to think about here is, this is an appropriate answer. However, we always want to simplify that all the way down. So let's think about the factors of 32. If I look at 32, I know that 32 is 4 times 8. Okay? Well, 8 is also 4 times 2, right? So if I were to rewrite my square root of 32, I'd have 4 times 4 times 2. My square root says I need to. I have 2 4s, so they get to escape. I have that 4 on the outside, square root of 2. Okay. So this is now our answer. And it would be plus or minus 4 square root, so 2. And then we go back and see which one, if there's any that don't work. Another way that you can write this, remember, whenever you get your prime factors out, you can rewrite it as exponents if that helps you see it. So I have 4 squared. I need to, I have to, so that's the number that escapes. A single 4. So if writing it as exponents helps you remember to not bring both numbers out, to only bring one out, then go ahead and write it as exponents. Either of these are okay. Whatever works for you guys, okay? All right, so we're going to put I'm going to put some examples up, and I want you guys to come up and work them, and they are going to be the same ones where we are only working with one variable, okay? And Mrs. Shepherd also has a flowchart, a paper here for you guys. It's going to be handed out. This will go over 39, 40, and 41. So we're going to talk through each of the sections of it. Once we're done with that, you'll be able to use this as a cheat sheet, and I'll go over it with you. Okay, so let's look at the first one. I've got 2x minus 5 plus 2x squared plus 2x equals 15. Okay, there's problem number 1. Number 2, x plus 1 squared minus 3 is equal to 7. Okay. Problem number 3, 4x squared minus 5 equals 31, and 2x minus 11 equals 5x minus 19. Okay, so here are 4 problems. Remember that the goal in each one is to solve for x. You want the value of x in each one of these.